There's testing that we can do here that can't be done anywhere else in the world. You take the price difference from flight test to ground test, the things that we can perform here, we can clean up a range that they can't get anywhere else because of our 100 dB of isolation that we can provide our customers, the clarity of the emitters, and just the time it takes. Flight test is so expensive, so we can do it for a fraction of the cost here on the ground, right here at the bath.
Originally built for the B-1 in the late 80s, the Benefield Anechoic Facility at Edwards Air Force Base is the world's largest anechoic chamber. One of the unique characteristics of this facility is its 80-foot turntable in the center of the chamber space.
The original setup of the turntable was Rockwell built this unit here, or this building rather, here for the B-1. And the purpose of the turntable was just simple rotation. So at that time, the turntable as it's configured now was perfect for that. Newer age aircraft, more GPS tracking than we used to use now. So now we need to be a little more precise, and we need to have more repeatability on certain angles. And as a turntable sits, we can't perform that. So we're going to upgrade the controls on it. Essentially what that's going to do is it's going to allow us to have more repeatability on certain angles and also more precise on the angles that we're looking for. Meaning if we want it exactly 145, we can get it exactly at 145.
We're going to want to set to 178 at 0.1 degree per second, excuse me.
Yeah, future copy plus 178 at 0.10 degrees per second.
Confirmed.
Test port 2, we ready to rotate? Port 2 ready to rotate. And temperature is 115. Rotation beginning.
Having a turntable is really beneficial. We are able to put aircraft or a system onto the turntable and do a full 360 rotation and collect data around it. We even hoist an aircraft and then we can tie it down to the turntable and rotate it so we can see how its radar will affect the backside of it, when most people don't normally see that because you don't have a full circle of antennas around it. We just have one point and then we rotate the set instead. You come inside the bath to mimic an outdoor range. That's really hard to do since we're enclosed by like a metal box. That's where all the RAM or radiation absorbent material comes into effect. It can take all of the stuff getting emitted off of the aircraft, it, for lack of a better term, soaks it up, and then when it comes back out, it's at a lower level, so it just looks like background noise to the plane, so it mimics like it's in a flying environment.
While we can't replace flight test completely, what we can do is we can narrow down that flight test by providing continuous 8-hour testing where you only get an hour or two in the air. We give you real-time data, post-test data, and that's a lot cheaper than spending all those hours in the air. So you can take what would essentially be a 20 or 30-hour flight test and condense that into a 2-hour flight test to just get the data that's not possible for us to collect here.
As air combat has evolved, electronic warfare plays a vital role in air superiority. Updating this one-of-a-kind asset will have a lasting impact on testing at the bath and national defense well into the future.